Today's lesson is over section 3.7b. We're still talking about rational functions, but we're going to move on to the second case. So the second case is when your degrees of the numerator and the denominator are the exact same. So our n and m are equal to one another, whether that be 1 and 1 or 2 and 2. That's what we're looking for. So when that happens, that means our horizontal asymptote is going to start moving. So it's actually going to be the leading coefficients of the numerator divided by the leading coefficient of the denominator. And then that ratio is actually going to get you your horizontal asymptote. Okay? And then also for the first example, we're going to have an example of when we have a hole. So I'll show you that here. Okay, so now sometimes we're going to have to factor both the top and the bottom. So that's what I'm going to do first, because it'll make it easier for us to find our vertical asymptotes and any x-intercepts or anything like that. So I get x minus 3 times x plus 4, or sorry, x plus 3. And then at the bottom I get 2x times x plus 3. Okay, now I'm going to go about this the same way I've been doing. So looking at the degrees of the top and the bottom, it looks like I get 2 on the top and 2 on the bottom for the highest degree. Now, because they're equal to one another, that means that we're going to have a horizontal asymptote that moves, so it's not going to be 0 this time. So I'm actually going to take the numerator's leading coefficient of 1 and divide the leading coefficient of the denominator by it, which is 2. So in this case, I'll get 1/2. So sometimes you do get fractions, sometimes there'll be whole numbers. It just kind of depends on the situation, okay? So now vertical asymptotes are normal, as what we've always been doing. I set the denominator equal to 0. So I'm going to set the 2x equal to 0, and that gets me x equals 0. But notice that in the top and the bottom, I have two factors that are exactly the same. This means that you're going to have a whole, because I could cancel them out, essentially. So a whole at wherever x plus 3 equals 0 is what I'm going to find too. So there's my x equals 0 for my vertical asymptote. And then solve the other one. That gets me x equals -3. So at x equals -3, I'm going to have a whole. And I'll show you how we graph that when we get to graphing. But I first want to find my x-intercept and my y-intercept. Okay, so just like we normally do for the x-intercept, you're basically setting the entire thing equal to 0. But since the denominator is not going to matter because it gets multiplied away and multiplied by 0, so it disappears anyway, I'm just going to set the numerator equal to 0, which is just the x minus 3. Because there's a whole at x plus 3, I'm not going to worry about solving that because I already know what that is. So I have an x-intercept at 3, 0. And then for my y-intercept, I plug in 0 for all my x's to see what my y would be. Now, in this case, because you have times 0 to both the terms there, you're going to get -9 divided by 0, which is undefined. So that means there's not going to be a y-intercept, which makes sense because we have a vertical asymptote at the y-axis. So that means we couldn't graph it there anyway, even if we wanted to. Okay, so I'm going to graph what I know. So we'll start with the horizontal asymptote after we sketch out some stuff. And so because it's 1/2, it's going to go in between the 0 and the 1. So do your best to kind of get it halfway in between. We're going to label it as such, so that'll kind of take care of the ambiguity there. Okay, now I'm going to graph my vertical asymptote at x equals 0. And then my x-intercept at 3, 0. Okay, so on the right side of x equals 0, I know what my graph is going to look like. So I can kind of draw that in if I would like. It's not going to cross the vertical asymptote anyway, so I'll just draw that in. Now, here this is where our hole comes in. So at -3, I should have something at that point. It's going to be a point of discontinuity. So without like those x plus 3's in, because if you leave the x plus 3's in, your function and you plug in -3, it's going to get 0. You're going to get undefined. So you're not going to find anything. So we're actually going to cancel them out, kind of like you would normally do if you wanted to simplify the fraction. So I'm going to cross them out. And that's going to leave me with x minus 3 divided by 2x. So now I want to actually plug in what -3 would be at that point. And so this will give me a place to put my actual hole. We're going to use an open circle as a whole. That's kind of how we graph it. So -3 minus 3 divided by 2 times -3, that gets me -6 over -6, which is 1. So at -3, commas 1, I'm going to actually draw a hole there and then complete my graph, kind of like it was an ordered pair or a point. And it fits in that top left section, so it's not going to cross either. Okay, so that's kind of how you deal with holes. Kind of treat it as an ordered pair a little bit, but you kind of have to cancel those out to be able to actually find that y value that you really want. Okay, letter B here, I need a factor once again. Now notice this time there are no factors that are the same, so I'm not going to have a hole on this one, so it doesn't happen all the time. But our degrees do match again, so our horizontal asymptote will be the top number divided by the bottom number, which in this case is 1/2 again. Vertical asymptote, set the denominators equal to 0, so 2x equals 0 and x plus 2 equals 0. So that gets you x equals 0 and x equals -2. Okay, and then from there, I want to look for my x-intercepts. So that means I'm going to set the numerator equal to 0. So x minus 4 equals 0 and x plus 1 equals 0. That gets me x equals 4 and x equals -1. So that means I have an x-intercept at 4, 0 and an x-intercept at -1, 0. Okay, and then I want to find my y-intercept, so I'm going to plug in 0 everywhere for x. And see what happens. But if you notice that because our vertical asymptote is x equals 0, we're not going to have one. But I can always check to make sure that my work is correct. So I get -4 divided by 0, undefined, so it didn't work like I thought. So then there's no y-intercept for this one, which makes sense, okay? So here I'll graph what I know. Start with the horizontal asymptote and graph it at y equals 1/2. Okay. And then I'll graph both of my vertical asymptotes. Okay. Now because I have 2 vertical asymptotes, this is going to make our graph start to be a little different and be a little odd. Okay. But I'll still graph my x-intercepts like I've been doing. So on the outside with that 4, it'll look basically the same. They'll still graph it where it connects. But on the middle there, it's going to do something weird. Now, I plugged in values myself, so I plugged in -1/2 and -3/2 to figure this out. But -1/2 was a positive number and -3/2 was a negative number. So that's how I got that looking graph in the middle. And then on the left side of x equals -2, I plugged in a -3, and that got me a positive value, so then I know it's graphed on that side.